This question is from GATE 2023, and the question is, in the circuit shown below, D1 and D2 are silicon diodes with cut-in voltage of 0.7 volt. Vin and Vout are input and output voltage in volts. The transfer characteristics is. So the question is like the diode are not ideal. It has a forward cut-in voltage of 0.7, so it requires 0.7 voltage to switch on. Okay, and we need to find the transfer characteristics Vin versus Vout. Okay, so here if you see here, there is a bias voltage of 1 volt and we have diode D1 and D2 here. So what happens when Vin is equal to 0? So when Vin is equal to 0, so that is, it is like a ground. This node will be positive and the diode D2 is now on. D2 is on while D1 is off. Right, so initially D1 and D2 is like D2 is on and D1 is off. If D2 is on, like D1 is off, and we will assume the condition when D1 is off, what happens to Vout. Okay, so when D2 is on, the circuit is like this. And here I have the Vin. Okay, okay, so this is on, so I have a potential drop of 0.7 here. So what is Vout here from this circuit? Vout is actually equal to this Vin voltage minus plus drop across the diode, right? So plus 0.7. So this is the voltage Vout. Okay, and so here if you see values of Vin, this diode D2 is on, right? So when Vin is equal to 0, D2 is on, and also when Vin is less than 0, D2 is on, right? Because this node will be negative, so and that is connected to the cathode of this diode D2. So that is always on when Vin is less than 0. So if I draw the transfer characteristics here, so Vin, this is 0 and yeah, so this is Vout. Okay, so at 0, so here when Vin is 0, Vout will be equal to Vin is 0 plus 0.7. So the Vout will be equal to 0.7. So Vout is actually 0.7 here, right? And when Vin is less than 0, Vout is actually equal to Vin plus 0.7. So when Vin reduces below 0, it will Vout will also linearly reduce. So it will be like this, right? Like at Vin equal to minus 0.7, minus 0.7 plus 0.7 is 0. So Vout will be equal to 0. And when V is less than minus 0.7, the Vout will be also negative, right? Thus this D2 becomes on. I mean off. Okay, so here D2 becomes off, right, when this node voltage minus this node voltage is less than 0.7. That is when the voltage 1 minus the Vin is less than 0.7, then D2 is off. Or when Vin is greater than, right, when I can take Vin to RHS, Vin is greater than 1 minus 0.7 or this is equal to 0.3. So when Vin is greater than 0.3, this D2 is off, right? So till that the Vout will be linearly changing, right, increasing or decreasing with Vin. So I can write like when Vin is 0.3 till 0.3, the Vout will be following the curve of Vin, right? Now what happens at Vin equal to 0.3, D2 is off and D1 is off. So what will be Vout? Vout will be equal to, so both the diode D1 and D2 is off, right? So whatever is a voltage at this node, that will be coming at Vout, or Vout will be equal to 1 volt itself. So here it is 1, right, 1 volt. So the Vout will be now 1 volt. Okay, and this continues until when D1 is on. So we'll see when does this D1 becomes on. So if you see here, so when D1 is on when this node voltage minus this node voltage is greater than 0.7, or V in minus this node voltage is 1 is greater than 0.7, or when V in is greater than 1.7 volt, the D1 is on. Okay, and when D1 is on, what happens? What will be V out here? So I will draw here. When D1 is on, so D1 is on when V in is greater than 1.7 volt, right? So when that is on, this is 1 volt. I have a resistor. This V out, and I have V in. Okay, when this is on, there will be a potential drop like this, plus minus, right? So V out will be equal to V in minus 0.7, right? And that happens at voltage V in greater than 1.7, right? So at V in equal to 1.7, V out is equal to 1.7 minus 0.7, that is 1 volt. So that is this line, right? That is at V in equal to 1.7, and for V in greater than 1.7, V out will proportionally change with V in, right? That is V in plus V in minus 0.7. So we will have a curve like this. It will increase with V in, right? So this is how the transfer carrier looks like. So here in the question, among the option, the right answer is this one, see 0.3, 1.7, right? So option is A. So this is a question from GATE 2020. The question is, on the circuit shown below, all the components are ideal and the input voltage is sinusoidal. The magnitude of steady state output V0 is dash voltages. So we need to find what is V0 here. Okay, so given the input is of 230 volt RMS, which means the input RMS is 230 volt. Okay, so what will be the peak voltage? Peak voltage will be 230 into root 2. So this is 325.26 volt. So this will be the peak input voltage. Okay, and here we have two capacitors C1 and C2 and two diodes D1 and D2, and given the diodes are ideal. Okay, so if this is the input signal V in, I'll call it as V in. Okay, so this peak is 325.26, and this will be equal to 325.26 minus 325.26, right? So here, if we carefully see, so it's a continuous signal, right? So in this negative half cycle, this diode is on, right? So during the negative cycle, this is minus, sorry, this is plus and this is minus, and there will be a flow of current like this. And if you see, D2 will be off. Okay, D2 will be off. So what happens? This capacitor will charge like this, plus minus, and since this is ideal, the capacitor C1 will charge to the peak voltage. That is, this will be charged to 325.26 volts. So voltage across C1 will be charged to 325.26, right? So that is during this negative half cycle. Okay, now we'll see what happens in the positive half cycle, that is during this one, plus minus. So this diode is off, right? So the voltage here, and this is on, D2 is on. So here the voltage at this node is actually V in plus the voltage across the capacitor VC1, right? And this voltage is plus, and so D2 will be on now, right? So what happens to this capacitor C2? The current will flow like this and it will charge plus minus, right? So what happens? It charges to its peak of this, okay, peak of this voltage. So I will call it as V0 is the voltage across the VC2, and the maximum voltage it will charge is V in max plus VC1, right? VC1 plus V in is the voltage here, and it will charge to the maximum voltage. So what is the maximum V in max here? V in max is 325.26 plus VC1 is 325.26. It's already charged, so it will be near to 650.5 volt, right? So the capacitor C2 will be charged to 650.5 volt. So that will be its steady state voltage. That will be its steady state voltage, right? So answer is 650.5 volt. So this is the next question. This is from GATE 2019. The question is, in the circuit shown, Vs is the square wave of period T with maximum minimum values of 8 volt and minus 10 volt respectively. Assume that the diode is ideal and R1 and R2 is equal to 50 ohm. The average value of VL is dash volts. Okay, so a square wave input is given. We need to find what is the average VL here, right? So here R1 is 50 ohm and R2 is 50 ohm, right? So we'll see what will be VL here. So we'll see first what happens during this phase, that is when the input is here plus minus 8 volt. So since it is plus here, this diode will be off now, right? So diode will be off. So what happens, and this is ideal, right? So it is like it's open circuit, so it will be like this. 50, 50, and here it is plus minus 8. Right, so what will be VL now? VL will be equal to 8 into 50 by 50 plus 50. So that is 4 volt. Right, so during the positive half cycle, the output VL will be 4 volt. Now we'll see what happens during the negative half cycle. So during the negative half cycle, okay, so during the negative cycle, half cycle, this will be minus, this will be plus, right? So since this is minus, this diode will be now on. So what happens? This will be directly connected since it's ideal, right? So we can redraw that circuit. It will be, this two node will be short circuited because of the diode is on. So what happens? This node and this node is short circuited. So it's like the both node are same. So there is no 50 ohm across that point. So I have 50 ohm here, and this is minus plus, right? Minus plus 10 VL. So what is VL here? VL will be equal to, since this is short circuited, same voltage, this same voltage will be available here. So VL is actually minus 10 volt. So we'll draw the output VL. Now VL is like this. This is 4 and this is minus 10. This is VL. T, so this node is T by 2 and this is T, right? So we need to find what is the average, VL average. So what is VL average? VL average will be equal to the net area, okay, between 0 to T, because it is repeating with period T, right, by the base T. Okay, so net area, I can say this is in area A1 and this is area A2. So A1 is actually equal to, so from here A1 is equal to 4 into T by 2 is the area here, and this is under rectangle, so A2 is equal to minus 10 into T by 2, right? So I can write 4 into T by 2 minus 10 into T by 2, that is the net area by its base, that is T, right? So T I can cancel, so it will be equal to 4 by 2 is 2, 2 minus 5 by 2 is, sorry, 10 by 2 is 5, right? So it will be equal to minus 3, so minus 3 volt. So this is the